So what we're going to do in this last section is we are going to do the first of several ways that we will apply factoring. And the first way we're going to apply factoring is solving a new type of equation. Okay, again, I'm assuming it's new. I'm going to present this like it's new. It's likely you have seen solving this type of equation in a previous algebra class. So here we are. We're going to solve things that have squares in them, and we're going to use this tool. The book calls it the zero factor property. This is just some basic arithmetic. Here's what it says. If two numbers have a product of 0, okay, meaning you multiply two numbers together and they are 0. So if I tell you this, if I tell you that A times B equals 0, what do you know about either the number A or the number B? One of them has to be 0, right? That's the only way you can get 0. So that's what my statement here is saying. If two numbers have a product of 0, then at least one of the numbers must be 0. If we were reading this in our math textbook, which I know you probably haven't even opened that up, I don't blame you. Said another way, if A times B is 0, then either A equals 0 or B equals 0. That is the more mathy way to say it. This is going to be our tool that enables us to solve things that have squares. Okay, so that's kind of our aim today. So the first two problems, I'm going to do one, you're going to do one. We're going to apply this zero factor property. So for instance, example 1, my example right here. I've got two things multiplied together. 3x minus 4 is the first thing, and x plus 8 is the second thing. I don't know what x is. I don't know what either of the values in those parentheses are, but here's what I do know. When I multiply those two things together, I get 0. So this is a situation where I can use the zero factor property. Here's what we do. We just say, oh, cool. I know 3x minus 4 times x plus 8 equals 0. So that means either 3x minus 4 equals 0 or x plus 8 equals 0. One of those two things has to be true. And now what I have is just two, hopefully, quick little equations to solve. You have the skills because we did this on the very first day of class when we first met each other. Okay, 3x minus 4 equals 0. First thing I'm going to do is I'm going to add 4 to both sides, and I get 3x equals 4. And then I'll divide by 3. And the first value here that would give me 0 is x equal to 4/3. The second one's a little quicker. I just got to subtract 8 on that one. And the second one is x equals -8. And you can see if I plug back in, I'm just going to do this with the -8 because it's a little quicker. If I plug back in, if I plug -8 into this first thing, 3 times -8 is -24. Minus 4 is -28 times. And then -8 plus 8 is 0. And so you get -28 times 0 equals 0. Perfect. So we're all of the equations we've ever solved in this class, we write our answers as solution sets. So I'm going to put my solution set, really the order of these numbers doesn't matter, but I'm going to put the smaller one first, the -8, and then the 4/3 second. There we go. That would be the solutions to the original equation. All right, you real quick, I'm going to give you 35 seconds. Go ahead and run through exercise 1. Write down the solution set for the values that solve that problem. Okay, so on this one, I've got my two factors. It's equal to 0. Here's the thing to note. I'm going to say this several times. This process we are going to employ only works if it's equal to 0. Okay? If that's equal to 5 or equal to 19, then you have to make it equal to 0. Okay, otherwise you can't use the zero factor property. But this one is equal to 0, so that means either the x minus 5 equals 0 or the 4x plus 7 equals 0. And hopefully you were able to tear through both of these by adding 5 on the first one, and you get x equals 5. That's the first member of my solution set. And then over here, I'm going to subtract 7, and I get 4x is equal to negative 7. Divide by 4, and the second one is negative 7 over 4. So my solution set looks like this: negative 7 over 4, comma 5. Remember to use braces. Don't use parentheses or brackets. This is not an interval. These are two separate values, only two. Okay, not an infinite number of values. Okay, good notation. All right, so if you're tracking with me so far, then the rest of this section has nothing new in it. Okay, that's the new information. Okay, so now what we're going to do is we just reviewed factoring a few minutes ago. We're going to use our ability to factor to solve this thing right here. This says x squared plus 5x minus 24 equals 0. What this is called right here is called a quadratic equation. Fancy math word, okay? Quadratic equation. So you're learning how to solve something new. If we were in college algebra, you would see that the quadratic equation is called a parabola. Okay, satellite dishes are in the shapes of parabolas, so that all the waves coming in bounce to the same place. That's one of the fun properties of parabolas you learn about that you use. If you're at a water fountain, when you hit the button and the water comes out, it's in the shape of a parabola. Rockets travel in the shapes of parabola. It's a very useful figure in application. That's why we learn how to solve these types of equations. So the process is pretty simple. I'm going to take this quadratic and I am going to factor it. It's equal to 0. That is essential, okay? 100% essential. You can't do this if it's equal to another number. What you would then do, and we'll see this at a later problem, is you'd put everything on the same side. And once that's done, I'm going to factor. So I'm going to unfoil my x cubed plus 5x minus 24. I think I said x cubed. I should have said x squared. Sorry, just getting too excited here. All right, so x squared is x times x. My signs that give me a negative 24 are a plus and a minus. And the two factors of 24 that are going to be 5 apart are going to be positive 8, negative 3. Okay. Nothing is new there. We talked about factoring. We've reviewed factoring. Hopefully you are feeling pretty good and confident about factoring. So now what I've done is I've written what I started with as a product of two things. They're being multiplied, equal to 0. It allows me to use the zero factor property. So here we go. I'm going to take the x plus 8 equal to 0. The x minus 3 equals 0. When I subtract the 8 from both sides of this first one, my first solution is negative 8. And when I add 3 to the second one, my second solution is 3. So my solution set becomes negative 8 and 3. Now, I'm not going to have time today to do this for every single problem, but for this problem, we're going to check one of the answers just to show you that it is going to work. So I'm going to just check the value 3 because it's a little bit smaller. So what we're going to do is we're just going to plug the 3 back in, and I'm just going to confirm for you that when I plug 3 back into this original equation, we are going to get 0. So here we go, 3. What is 3 squared when I plug 3 into this first term? 9 plus, what's 5 times 3? 15 minus 24. And when you pop that into your calculator, 9 plus 15 is 24, minus 24, what do we get? 0. Okay, you just solved the quadratic equation. Okay. Same thing would happen if we plugged negative 8 in. But again, just for time's sake, I'm not going to plug in. But again, you can check all your answers. You can know with 100% certainty if you got the problem right or not. All right, exercise 2. It's already in the format to solve, so go ahead and factor, and then come up with your 2 solutions for the solution set. All right, so the first couple examples, I tried to make the factoring nice and direct and straightforward because I don't want to conflate skills here. So x squared minus x minus 6 equals 0. So we're going to unfoil this. X squared has to be x times x. The negative 6 tells me my signs are positive and negative. They have to be different. And what are my two values that I'm going to use? Okay, we're going to use positive 2, or use a negative 3 because they need to add up to negative 1. Great. Again, that's not the most complicated factoring you've seen. Okay, but now this is the new thing. We're going to solve this. So the x plus 2 equals 0, or the x minus 3 equals 0. In this first case, the x value is negative 2. In this second case, the x value is 3. And there's my solution set, negative 2 and 3. If you got a question, comment, or concern, raise your hand. Let's talk about it. I'm happy to help you in any way I can. Exercise 3, another fairly straightforward factoring to go ahead and solve that. X squared minus 49 equals 0. X squared minus 49. X squared minus 49, that's a difference of squares. So I'm going to, here's my parentheses. X squared has to be x times x. 49 is 7 times 7. And then for every difference of squares, you always have plus 1 minus the other. The signs have to be different. There's my two factors. So we'll just go through the process. You're going to do a bunch of these, so you'll get nice and quick at doing this. And I don't mind if you skip some steps on this last part. Just make sure that you're consistently getting the answers right. If you're subtracting 7 here, you don't want to write that down. You just want to say, okay, x is negative 7. I get it. That's fine. And then here I'm going to add 7, and you get x is equal to positive 7. And there's my solution set. The solution set is the values negative 7 and then positive 7. Exercise 4. Okay, so what we're going to do, the process doesn't change. Okay, you've seen everything that there is to see. Okay, I'm just going to show you some different things that you have to consider. So exercise 4, is that equal to 0? No. So what do I have to do as a first step on exercise 4? Yeah, I'm going to subtract that 10x to bring it over. And then always make sure your polynomial is in descending order. Your squared term is first, your plain x term is second, and the number is third, so that you can factor. So do those two things. Bring that 10x over, and then factor what's left and come up with your solution set. Have to work. So if you didn't hear the question, when you're plugging in your answers, both should work. Have both not worked on any of the ones that we've done so far? On this one right here, the -7? Okay, well, let's plug it in. So let's confirm that -7 is a solution to exercise 3. So if you're still working on exercise 4, that's great. Keep going. So when I take -7 and I plug it in right here, what's -7 squared? What do you get with -7 times -7? You get positive. So here's what not to forget. Sometimes students forget this, so I totally get it. When I plug -7 in here, it's -7, and I'm squaring that whole thing because the negative goes with the 7. Okay, so don't leave, when you take -7 squared, it's not -49. Okay, so that's going to be +49, and then -49, that will equal 0. -7 times -7 is +49. Okay. Great question. I'm glad you're trying those out and confirming. It's great. All right, so let's look at exercise 4 here. Let's see how you did. Again, if there's other questions like that one, that was a great question. I love it. So we've got x squared minus 10x plus 21 is equal to 0. That's the key. It has to be equal to 0. I put the 10x in the middle, okay? The squared term first, the x term second, the number term third. That should always be your order. So now we'll unfoil this. X squared is x times x. This time, the 21 is positive. That tells me the signs have to be the same. And the -10 says they both have to be negative. And the two factors of 21 that are going to add up to 10 are 7 and 3. So that tells me that x minus 7 equals 0, or x minus 3 equals 0. When I add 7 to both sides of this one, that my first solution is x equals 7. And when I add 3 to both sides of the second one, the second solution is x equals 3. My solution set is 3 and 7. If you're confirming as we're going along, when you plug either of those into the original equation, it should work out that they provide a true statement. All right, so exercise 5. Okay, again, we're just seeing problems with different types of factoring. So this one, you might remember the first thing you look for in anything you factor. Exercise 5. So on exercise 5, notice there's only 2 terms here, and they both have a common factor. The common factor between 3 and 12 is 3, and x squared and x, I can take an x out of both of them. 3x squared, when I factor out the 3x, leaves me x. 12x, when I factor out the 3x, leaves me plus 4. Okay, there's my 2 factors. So this one's a little different in the 2 factors than the previous one. So if you didn't know what to do from here, I get it. That's why we're doing examples. It's just so I can show you all the different things you might see. So the first factor is the 3x. So we say that could be 0, or the x plus 4 could equal 0. Now this first one is 3 times x. So to get the x by itself, we divide by 3 on this one. And so that means my first answer is x equal to 0. That's the first solution to that quadratic equation that we started with. If I plug 0 in both places, I'm going to get 0. And then the second one, when I subtract 4, I get x is equal to -4. And again, you can verify that. It's going to work out just fine. And when you do plug in that negative, don't forget, we square it. So -4 squared is +16 is how that would work out. And so then my two solutions are -4 and 0. There's my solution set. All right, give exercise 6 a try. It's another one with a common factor that you got to look at. This one has a common 3 to all the terms. Now notice this one, there's not an x in common to all the terms. So we'll talk about what the implications of that are in just a minute. I did these two problems back to back to show you the contrast. Okay, so I'm just factoring a 3. So 3x squared when I factor out the 3 leaves me x squared. 21x when I factor out the 3 leaves me 7x. And then 36 when I factor out the 3 leaves me plus 12. Okay, that 3, I factored it out, so I'm going to carry it along with me. X squared, I'm unfoiling, is x and x. And the two factors of 12 that are going to add up to 7 are 3 and 4. Equal to 0, so I can use the principle of zero products. Here's the thing to notice. In the previous problem, exercise 5, notice right here, there was a 3 and an x. There was a variable. That's why I took that 3x and set it equal to 0. Okay, it could be equal to 0 when x is. This one, there is no variable. Three is just 3. 3 is never going to be equal to 0. So there's nothing to do with that when there's no variable. Just ignore it at this point. All you care about now is where the variables are. So either the x plus 3 can equal 0, or the x plus 4 can equal 0. So in this first case, I subtract 3 from both sides. Okay, you probably don't even need to write that down, but I'm going to just to be thorough for you. And then I'm going to subtract 4 on the second one, and I get x is -4. And so my solution set just contains those two values of x, -4 and -3. Since 3 can't be 0, that is not a solution. That is just the number 3, and you ignore it. All right, we're going to flip the page. If you got a question, be sure to ask it. Exercise 7, there's another common factor, and it will be a variable. So this one, just to give you a little hint, there's going to be 3 answers in your solution set to exercise 7. So on this one, the common factor is not a number. The common factor is an x, because I've got x cubed and x squared and x. So I can factor an x out of those three terms. So again, that's a variable. That can equal 0. So that's going to count as far as my answers are concerned. When I factor out the x cubed, I factored out an x, that leaves me x squared. 5x squared, I factored out an x, that leaves 5x. And then negative 50x divided by x is negative 50. And so there's my trinomial. That x, that's factored out. That's part of what I need. I'm going to unfoil what's in the parentheses. So x squared is x and x. The signs of my negative 50 are a plus and a minus. And then the two factors of 50 that are going to be 5 apart are 10 and 5. So I've got three factors there. I've got three factors that have an x in them. So there's going to be three solutions. The first one is if x equals 0. So if I just plug in x equals 0, you can see it makes each of the terms 0. And so I would get 0. So hopefully that solution kind of it makes sense. It's straightforward. X plus 10 equals 0. So when I subtract 10, that means my second solution is negative 10. And then the third one is x minus 5 equals 0. And so you solved your first cubic equation. You don't see too many cubic equations because they get a little more difficult. So that's a pre-calculus thing that you'll start if that's where your math destiny takes you. Okay, so negative 10, 0, and 5, those are my three solutions. Examples 8 and 9 that we're going to go through here in the next few minutes. It's the same process. The only difference on example 8 is there's a number in front of the squared. Now you gotta I'm gonna factor it by grouping. If you have another method of factoring, go ahead and employ it. So we're going to run through this process. It's going to be the same process we use on exercise 9. Okay, so again, when there is a number in front of the squared term, this is the method that I showed you. We're going to take that number 2, we're going to multiply it by the last number 5, and 2 times 5 is 10. Since it's a positive 10, that means that my signs are going to be the same. And since I want them to add up to negative 11, they're both going to be negative numbers. And then the two factors of 10 that are going to add up to 11, well, there's only two choices of pairs of factors. Either 2 and 5 give you 10, or 1 and 10 give you 10. And so the ones that add up to 11 are going to be the 1 and the 10. So now my grouping, I'm going to take the 2x squared, then I'm going to have minus 1x, and then minus 10x, and then plus 5, that equals 0. As I've said before, I'm just saying these things again, so hopefully maybe one of the times I say it, you'll remember it. All I've done, thing I've accomplished is I've taken this polynomial that had 3 terms and I've made it into something with 4 terms. Okay, that's exactly equivalent. And that way, what I can do now is I can proceed by grouping. And out of the first 2 terms, I can take an x, and I have 2x minus 1 left. Out of the second pair of terms, I'm going to take a negative 5. And when I do that, I have 2x minus 1 left. My grouping worked, as makes me happy. Otherwise, I wouldn't know what to do next. So 2x minus 1 is the factor they have in common. And then x minus 5 is what's left over from each term. So that's my second factor. And that equals 0. And now I can solve. So the busy work of this problem was the factoring. Once you've got it factored, I don't think the rest of it is too difficult to run through. So the 2x minus 1 equals 0, or the x minus 5 equals 0. Those are my two choices. I'm going to add 1 to both sides of this first one, so I get 2x equals 1. Then I'm going to divide by 2, and my first answer is 1/2. Okay. Fractions are perfectly legitimate answers to quadratics, so don't get worried that you've done something wrong. The second answer is 5. There's my whole number. And so my solution set is 1/2 and 5. Those are the two solutions to my original quadratic equation. All right, if you got anything you want to interject, please do it. You're not interrupting me. I got nowhere to be except here with you. Exercise 9, same thing. So we've just factored something with a 2 in front of the x squared. Now you've got a 6 in front of the x squared. Process is going to be identical. All right, so let's see how you're doing. I promise you this factors. Again, on the test, everything will factor. I'm not trying to trick you. I'm just trying to see if you can factor. So I'm going to multiply that first and that last. So 6 times the -7 is going to give me -42. Since it's negative, that tells me that my signs have to be a negative and a positive. I've got one of each. And I need the two factors of 42 that are gonna be 19 apart. And so I don't know how good with your multiplication tables you are, but 6 times 7 is 42, but 6 and 7 are 1 apart. That's not going to do it for me. But here's why I start there. And here's what you can do. I've now broken it down at least a little bit. And so you can say, oh, 6 I could break down further. 6 is 3 times 2. So I can say 3. How many times does 3 go into 42? Well, 3 goes into 42, 14. So 3 times 14 would give me 42. But again, they are not 19 apart, so that's not the right pair of factors. But okay, everything you eliminate, you're getting one step closer to the answer. Okay, so 6 was 3 times 2, so 42 is 2 times 21. I just using my calculator. Okay, I've just done the problem before. Okay, so you divide 2 into 42, you get 21. Oh, there we go. Those two things are 19 apart. Got it. Okay, so it's going to be -21 and +2. So again, don't be afraid to use your calculator. Okay, you're not messing anything up. You're just eliminating all the things that don't work so you can find the thing that does. So now we'll go through the grouping. We've got 6x squared minus 21x plus 2x minus 7 equals 0. So I took my 3-term polynomial, made it 4 terms so that I can group. And out of the first 2 terms, which are a 6x squared and a minus 21, I can take a 3x out of both of those. So 6x squared divided by 3x is 2x. Negative 21x divided by 3x is negative 7. And even though there's nothing in common to the last 2 terms, I do see that the last 2 terms are 2x minus 7, which is what I have in parentheses. So I'm just going to throw some parentheses around that. The grouping worked because I got the same thing. So I've got 2x minus 7. What's left from the first term is 3x. What's left from the second term is plus 1. And again, I'm guessing that's probably the hard part to the problem. I understand factoring and getting comfortable doing that. That's a process. You just got to practice. From here on out, I think this is the less stressful part, at least in my opinion. So the first one, I'm going to add 7 and get 2x equals 7. And when I divide by 2, I get x is 7 divided by 2. The second one, I subtract 1 and I get 3x is negative 1. And when I divide by 3, I get x is negative 1 divided by 3. And there's my 2 solutions. I'm going to throw them into a set. I've got negative 1/3 and I've got 7 over 2. And there we go. We're done with that problem. All right, you're almost done. 2 more problems. Okay, the factoring on these problems is not going to be as difficult as the last 2. The thing that I'm just trying to illuminate for you here on exercise 10 is don't be lulled into the trap that on the left I've got something factored. On the right, I don't have 0. Okay, so it's useless to me. So here's what you have to do. Sorry about this. It happens sometimes. You're going to multiply the left back together. Then you're going to bring the 21 over. So it'll be equal to 0. Then factor. The factoring won't be too bad. I made it nice and relaxing. Okay, so multiply, then bring the 21 over, factor, solution set. Then if you finish that one, that's essentially the same thing we're going to do on exercise 11. There's just more terms. But again, it's going to become something that'll be nice and relaxing to factor. All right, so I'm going to do my first outers, inners, lasts on the left. So I've got x plus 8 times x minus 2. So my firsts, x times x, give me x squared. My outers, x times negative 2, give me negative 2x. My inners, 8 times x is plus 8x. And then 8 times negative 2, that's my lasts. That is negative 16. And that's equal to negative 21. I'm going to do 2 things at once. If you'll allow me, I'm going to combine those like terms on the left, and I'm also going to bring the 21 over. Okay, so I'm just going to do this to conserve a little space here. So I'm going to add the 21 to both sides to get that 21 over and make this equal to 0, which is the key. And when I do that, I've got x squared, negative 2x plus 8x, that is positive 6x. Negative 16 plus 21 is plus 5, and that's equal to 0. And as I promised, that factoring is not the worst set of numbers that we've encountered over the course of our unit here. So I'm unfoiling what I've got. X squared is x and x. The 5 tells me the signs are going to be the same. The 6 tells me they're both going to be positive. And then there's only 2 factors of 5. There's not a whole lot of choices. It's 1 and 5. Do 1 and 5 add up to 6? Yes, they do. Last time I used my calculator, they sure did. And so that means either x plus 1 equals 0 or x plus 5 equals 0. And so that means my 2 solutions are negative 1 and negative 5. And again, you can check those in the original equation. They will check out. They're going to be perfect. Just for time's sake, I have not been doing it. That doesn't mean it's not a valuable thing to do. All right, we've got just a few minutes left, so I'm going to give you 2 minutes on the last one, exercise 11. It's the same sort of thing. You've got to FOIL first, then you got to bring everything over on one side. The factoring that results will not be too bad, and then you can come up with your solution set. All right, just for time's sake, I don't want to go over. I like to let you out on time, as you know. So here we go. I'm going to get started. So if you're not quite done, I apologize. So here we go. I'm going to FOIL what's on the left and what's on the right. So on the left, I've got 2x times x, that's 2x squared. My outers, 2x times 5, that's 10x. My inners, 1 times x, that is 1x, or just x. And then my last 1 times 5 is 5. On the other side, my firsts, x squared, outers, 3x, inners, 11x, lasts, 33. Just going to mop this up a little bit and collect my like terms. So I've got 2x squared plus 11x plus 5 on the left. Then I've got x squared plus 14x plus 33 on the right. I'm going to move everything over onto the left-hand side. Okay, so that means I'm going to take this x squared and move it to the left by subtracting x squared. I'm going to take the 14x and move it over to the left by subtracting 14x. And then I'm going to take the 33 over to the left by subtracting 33. And when I do that, 2x squared minus x squared is x squared. 11 minus 14 is negative 3x. 5 minus 33 is negative 28. And on the other side, I have 0. And at long last, I'm done with the busy work. I can finish this problem up. Oops, that's an x squared, sorry. I'm unfoiling. X squared is x and x. Since the 28 is negative, my signs are a positive and a negative. And the two factors of 28 that are 3 apart are negative 7 and then plus 4. My zero product property, take those two factors, set them equal to 0. The first solution's negative 4. The second one, when I add 7, will be plus 7. And there is my solution set. All right,